On 17 and 18, you are told that segment BA is a tangent and segment BD is a secant, and they're intersecting at point B, which is outside the circle. So remember, when it's asking you to find AB and CB and there's not a symbol used, it's talking about a length there. A measurement between those 2 points is what you're being asked to find. So I took the drawing that's being used for 17 and 18 and made it into 2 separate drawings so you could see the changes that are being made. So these are individual problems, they don't build on one another. So for number 17, you're given the length of BD, which is the whole length of the secant, to be 18. You're given BC to be 8, which is the external part of the secant, and you're asked to find AB, which is the length of the tangent. So remember, if the intersection of the segments is outside the circle, the relationship is whole times external equals whole times external. So the whole length of the secant is 18 times the external part is 8. You don't need to add those two numbers together since the 18 is already the whole length of the secant. For the tangent, the whole and the external part are your whole length of the tangent, which is x, so x times itself is x squared. So when you do the 18 times 8 and get 144 equal to the x squared, you can find x by taking the square root of both sides, so x equals 12. On number 18, you're given AB, the length of the tangent, to be 16. You're given DB, the whole length of the secant, to be 32, and you're asked to find CB, which is that external part of the secant. So again, we have that whole times external equaling the whole times external relationship since they intersect outside the circle. So for the secant, the whole length is given, it's 32, times the unknown external part, which we'll call x, is equal to the whole times external of the tangent, which is 16 times itself, or 16 squared. So we get 32x on the left side, and when we square the 16, we get 256, and when we divide both sides by the 32, we get x equals 8.